Triangle. What is a triangle? A triangle has three sides and those three sides are joined at three vertices. So we can define a triangle as three sides joined at three vertices. Now this can be made like this. Now this triangle is having three sides meeting at three vertices. If I want to name it, I can name it as ABC or ECD or whatever we want, right? But it being made like this, it has divided the total area into two parts. Now you have the interior of the triangle. This is the interior because it is lying inside. So this is the interior, whereas the part lying outside the triangle is considered exterior. So next what we are going to discuss is the interior angles and exterior angles. What about interior angles? Interior angles are angles that lie within the triangle. For example, this is the triangle ABC. Here these three angles, angle A, angle B and angle C, are lying inside the triangle. So these are known as the interior angles of this triangle ABC. Whereas when are the exterior angles formed? Exterior angles are formed when any side of triangle is produced beyond a vertex. Now for example, there was this same triangle ABC. I have extended its side beyond this vertex B. I have extended BC beyond B, due to which I have got this angle, right? Similarly, I have extended this side AB beyond A, so I have got this angle, and I have extended AC beyond C to get this angle. So these are the angles formed outside the triangle, you can say. So this forms the exterior angles. We have three exterior angles for a triangle and three interior angles for the triangle. So now we have the property which says that exterior angle of a triangle is always equal to sum of two opposite interior angles. Now that means, for example, I will name this as angle 1. I'll name the other angles as 2, 3, 4, 5 and 6. I have named all the interior angles and I have named all the exterior angles. If I want to write the measurement of angle 1, that is the exterior angle. As per the property, the exterior angle is equal to the sum of two opposite interior angles. Interior angles are these three, but the two opposite ones for angle 1 would be 2 and 3. So angle 1 will be equal to the sum of angle 2 and 3. Similarly, if you want to write it for angle 5, this would be equal to the sum of angle 3 and angle 4, because for angle 5 the two opposite interior angles are 3 and 4. So 3 and 4 sum done together will give you the measurement for angle 5. And similarly for the third exterior angle, angle 6, you are going to get the sum of 2 plus 4. So this was as per the property 1 that we have discussed, which says that any exterior angle of a triangle is always equal to the sum of two opposite interior angles. Now property number 2 is the Pythagoras property. Before doing this property, I want you to understand the classification of triangles, then we will get back to this property. First of all, let us do how the classification of triangles is done. Classification is done on two bases, based on sides and based on interior angles. Now if you consider sides, you have divided the triangle into three types, that is scalene triangle, isosceles triangle and the last one is equilateral triangle. Now these three types are because in scalene triangle you have no sides equal and no angle equal. That means if in a triangle there is no side and no angle equal, that means all the three angles are different and all the three sides are having different measurements. That will form a scalene triangle. Isosceles triangle has two sides equal and two angles equal. That means out of the three angles of a triangle, two angles are going to be same and two sides are going to have the same measurement. That will form your isosceles triangle. equilateral triangle has three sides equal, right, and three angles equal. Now that means all the three sides, or you can say all the three angles of the triangle are going to be equal. So that will form a equilateral triangle. This was done on the basis of sides, right? Because it was decided how many sides are equal. Based on that, we have divided it into three types, that is scalene, isosceles and equilateral. Now we have done the classification based on interior angles, and that is acute triangle, obtuse triangle or right angled triangle. So in acute, obtuse and right angle triangle, what is the difference? For acute triangle, we have all the three angles as acute. Now what does acute means? Acute means they all are having measurement lesser than 90 degrees. So that means if in a triangle we have three angles, if all the three angles of a triangle are less than 90 degrees in measurement, that will be an acute triangle. Similarly, we have the next one based on angles, that is obtuse triangle. In obtuse triangle, we have any one angle greater than 90 degrees. Now, out of the three angles that we have in a triangle, we are going to have one angle at least which is going to be greater than 90 degrees. That will form the obtuse triangle. If in a triangle any one angle is 90 degrees, that will form a right angled triangle. Now, before moving forward, I have made some triangles over here with different measurements. Let us try and identify which one out of them is which category, right? So first of all, let us consider the first one. Here we have the three angles as 75, 45 and 60, and the three sides are 5, 6 and 7 centimeters. That means all the three angles are having different measurements and all the three sides are also having different measurements. So this means this forms the scalene triangle, right? So I'll write scalene triangle on this. Next we have 40, 70 and 70 degrees as the angles and 6, 6 and 7 centimeters as the sides. So here we are having two angles and two sides equal. So we can consider it to be an isosceles triangle. So I'll write here isosceles triangle. Next we have each side is equal to 5 centimeters and each angle is having the measurement of 60 degrees. So this is an equilateral triangle. So I hope you are clear now with the types of triangles based on sides. Now let us consider the others. Here we have the triangle having three angles as 55, 85 and 40. Now all the three angles are having different measurements, that is correct, but we have not yet provided the sides measurement. So we cannot clearly identify it to be a scalene one, but we know that if in a triangle all the three angles are less than 90 degrees, that would make an acute triangle. So I'll write over here acute triangle. Next we have the measurements as 100, 30 and 50. Here we can see one angle out of the three is having measurement greater than 90 degrees. So this triangle represents the obtuse triangle. So I will write obtuse triangle for this one. And this one is having a angle equal to 90 degrees. If we have any one angle equal to 90 degrees, the triangle is termed as the right angled triangle. So we'll write over here the right angled triangle. And similarly for this one, here also we are having one angle as 90 degrees. So we can consider this also to be a right angled triangle. That was the classification of the triangles based on sides and based on interior angles. Coming back to my property number 2 now, which is valid only for right angled triangles. That means the triangles must have one angle equal to 90 degrees. Only then this property is going to be applied. What is the property saying? The name of the property is Pythagoras property. As per this property, we have the hypotenuse square as the sum of squares of perpendicular and base. That means if you do the hypotenuse square, that must become equal to the sum of square of perpendicular plus the sum of you can say the sum of perpendicular and base both together. But here this is valid only for the right angle triangle. That means if I take any of these, both are my right angle triangles, if I want to name them, I want to number their sides rather, it would be 3, 4 and 5 for example. What is my hypotenuse in this? Hypotenuse is the side that is opposite to the largest angle, that is 90 degrees. The side opposite to 90 degrees is the hypotenuse. One is your base and the other one definitely is your perpendicular, right? So what you will do, you will place the value of h, you will place the value of b and place the value of p in the Pythagoras theorem, and you can cross check whether it is satisfying or not. Similarly for this one, for this triangle, which will be the hypotenuse, because 90 degrees is over here, the side opposite to 90 degrees is this one. So we write hypotenuse here. We can take this as the base, so other one is going to be the perpendicular, or you could have taken that as the base, then this would have become your perpendicular. So Pythagoras property is valid only for right angle triangles, no other triangle. So for any right angle triangle, if h square is equal to p square plus b square, that will satisfy your Pythagoras property.